Hello everyone, my name is Dr. T.S. Kurne, Department of Statistics, Rajarshi Chhatrapati Shahu College, Kolhapur. Today we discuss the expectations of sum of square, mean sum of squares in CRD designs. So first we discuss the expectation of mean sum of square due to error, and in this CRD there is a second expectation of mean sum of square is the due to error. So first here we see the expectation of mean sum of square due to error due to treatment. So sum of square due to treatment is s square. For mean sum of square treatment is summation over I ri y dot bar minus y dot dot double bar y double dot bar bracket square. And the mathematical model of CRD is Yij is equals to mu plus alpha I plus epsilon j. Here I varies from 1 to V and j varies from 1 to Ri. Now this mathematical model, we want these two terms yi dot bar and y double dot bar from this mathematical model. So first we summing over I and j and divided by n, we get this term as a y double dot bar. So first summing over I and j and divided by n bar to the whole mathematical model. Then finally we get y double dot bar is equals to mu, because this double summation is converted into n get cancelled, then remains only mu. Here we remain, this term is based on I, so summation over aj is converted into ri. So this terminology is summation over I ri alpha I divided by n, and this is the term is converted similarly as epsilon double dot bar. So the in second term the numerator is 0. So this equation is converted into y double dot bar is equals to mu plus epsilon I, because this terminology get converted into 0. So first term is get. So for second term means yi dot bar, we are summing the mathematical model over j and divided by ri. So we get this summation over j yij divided by ri is yi dot bar. This terminology converted into mu. This term is converted to alpha and last terminology is epsilon I dot bar. So these both quantity are substituted into equation 1. Then equation 1 becomes sum of square due to the treatment is summation over I ri mu plus alpha I plus epsilon I dot bar minus mu minus epsilon double dot bar bracket square. So here mu get cancelled, remains only alpha I epsilon I dot bar minus epsilon double dot bar. Then this quantity is considered as this quantity is A and this quantity is B. So we expand the A plus B bracket square is A square plus B square plus 2AB, and taking summation over outside. So then taking the summation inside, this quantity is converted into summation over ri alpha I square, summation over I ri this epsilon I dot bar minus epsilon double dot bar, this quantity, and this quantity is also similar. So here first quantity remains same, second quantity also remains same, third quantity summation over ri alpha is 0. So this quantity converted into 0. Then first term as it is. Now this bracket is a minus b bracket square expanded as a square minus 2ab plus b square, and then summation and ri taken into inside, then converted into the sum of square of treatment is summation over ri alpha I square, and this terminology taking converted into like this. And by getting a simplification, of this quantity Ri summation over 2 times summation over I Ri epsilon I dot bar into epsilon double dot bar is 2 remains same, epsilon double dot bar is constant, takes as outside, and this quantity is 2 same is as it is. If epsilon I dot bar is expanded into epsilon ij divided by a summation over j, then finally quantity we get as 2 into n into epsilon double dot bar, because we get and simplification this middle term get and substitute into equation 2, then equation 2 becomes, by simplification we get sum of square due to the treatment is summation over I ri alpha I square plus summation over I ri epsilon I dot square minus n into epsilon double dot bar square. We want expectation of sum of square. So taking expectation of both sides we get, then taking expectations and then add the expectation into inside. This is the constant quantity. We only add expectation on epsilon ij. So before we discuss what is the value of expectation of epsilon I dot square in the estimation of parameters. So summation over ri alpha I square plus this quantity is sigma I square divided by ri, this quantity is sigma I square by n. So by simplification we get the whole value is expected value of means sum of square due to the treatment is summation over ri alpha I square plus v minus 1 sigma I square, and dividing both sides by mu minus 1, because the formula for mean sum of square is sum of square divided by its degrees of freedom, and degrees of freedom for the treatment is v minus 1. So we have take expectation of mean sum of square. So the formula is small s square. So divided by both sides v minus 1. Then finally we get the expected value of mean sum of square due to the treatment is equal to summation over I ri alpha I square divided by v minus 1 plus sigma I square. But this is not bias, this is not unbiased. This bias quantity is added over here. Hence under H naught, what is the hypothesis, null hypothesis for the treatment effect? All treatment effects are same, as that is effect equal to 0. So mean sum of square due to the treatment provides an unbiased estimate of sigma square, because when this value is taken as equivalent 0, this summation over quantity is taken converted into 0. So finally we get the expected value of mean sum of square due to the treatment is equals to sigma square. It is unbiased when under H naught, otherwise it is a biased quantity is added. So only and only if under H naught the mean sum of square due to the treatment is unbiased estimate of sigma square. Thank you.